In 1996, a NASA research team headed by Dr. David McKay reported the discovery of fossilized bacteria in a 4-pound, 4-billion-year-old Martian meteorite. The microfossils have all the characteristics of bacteria, including segmentation, a head, and a tail. They also lived and died in large colonies alongside and within organic residue typically produced by bacteria. As the bacteria discovered in the Martian meteor are not associated with frigid climates, and as no fossils were found on the surface, there is no possibility the meteor was contaminated with bacteria after it crashed to Earth in the Antarctic. All the microfossils were found within and not on the surface of the meteor. The Martian meteor, referred to as ALH 84001, was a 4-billion-year-old piece of the red planet, remnants from a time when Mars had oceans, rivers, lakes, and streams. Some of these bacteria lived and died in a watery environment, and were fossilized when their remains were covered with wet organic residue. Apparently, this piece of Mars had been flung into space when a huge asteroid crashed into the red planet, ricocheting pieces of Martian debris far into space. Eventually, it fell to Earth, landing in the Allen Hills regions of the Antarctic, where it was discovered peeping out from beneath the snow. Using technologically advanced high-resolution scanning electron microscopy and laser mass spectrometry, NASA scientists discovered clusters of microbes. Some were egg-shaped, while others are tubular. Many obviously had a head and a tail, and were sequentially and uniformly structured, similar to other microbes. Many are strikingly similar to iron-eating bacteria and microscopic fossils of the tiniest bacteria found on Earth, called nanobacteria. The only microbes similar to the Martian bacteria are found in salt deposits in an iron ore deep beneath the Earth. Therefore, it is not reasonable to assume the Martian bacteria are due to contamination, as the meteor was found in Antarctica. NASA scientists also found carbonate minerals and carbonate globules. This organic residue was formed by these creatures when Martian water seeped into the cracks when this rock was still part of Mars. The carbonate residues were formed in water, and where there is water, there is life. Microscopic oxygen and iron minerals called magnetite were also found in the carbonate globules, as well as iron and sulfur grains. These minerals are only found together when they are created biologically and are identical to those produced by bacteria. In fact, 25% of the magnetite in ALH 84001 occurs only in association with biological activity. They are the byproduct of iron-eating hyperthermophiles who metabolize and convert iron oxide to magnetite. Organic molecules called polycyclic aromatic hydrocarbons, PAHs, were also discovered. PAHs are formed when bacteria die and begin to decompose. These PAHs are different from those found in Earth's atmosphere and are unlike 99% of all PAHs found on Earth. They were also discovered inside but not on or near the outside of the meteor, which rules out contamination. Moreover, the PAHs were found adjacent to the carbonate globules, which were also biological in origin. Thus, the evidence is conclusive and from multiple sources. These creatures lived and died on Mars over 4 billion years ago. They lived at the same time life was appearing on Earth, and during a time when both planets were being pounded by meteors, asteroids, and oceans of frozen ice. In 1999, fossils were found in 2 additional meteors that had come from Mars. According to Dr. McKay of NASA, the Martian bacteria resembled Earth bacteria in the process of reproducing. These were found in a 1.3 billion-year-old Martian meteorite that landed in Nakala, Egypt, and a 165 million-year-old Martian meteorite discovered in Shergodi, India. Thus, there is evidence that living creatures have populated Mars for much of its history, from 4 billion years until 165 million years ago. Further, we know these meteors originated on Mars based on measurement of gases trapped in the meteorite's interior. The trapped gases match those measured in the Martian atmosphere by the Viking spacecraft in 1976. And we know that Mars was once awash with water, lakes, rivers, streams, and oceans. And like the oceans of Earth, much of the Martian water must have also come from space. And where there is water, there is life. In fact, there is still evidence of water on Mars, including frozen ice at the poles and what appears to be shallow pools of water on the surface. What became of the oceans of Mars is still a mystery. Nevertheless, hundreds of thousands of years ago, Mars may have been lush with life, and evidence of past life in the oceans of Mars can still be found on the surface. These small round stones, photographed by NASA's rover, the Opportunity, appear to be hematite, an oxide of iron. Hematite is produced biologically. On Earth, hematite is also created when exposed to large amounts of water, creating over time a spherical ball that pops out onto the surface after considerable water erosion. However, these round Martian balls were found not only on the crater floor, which may have once been filled with water, but on the soil above the outcrop of the crater. Unless these balls rolled uphill, this indicates a biological source. On Earth, hematite is a waste product produced by a common species of bacteria, Salmonella. In the absence of oxygen, Salmonella metabolizes minerals such as iron and excretes hematite. The only other creatures on Earth which create similar spherical balls and which lives around large bodies of water are crabs. Crabs are ancient and can live even at the bottom of the frigid ocean beneath thousands of pounds of pressure. However, they first crawled forth from the sea hundreds of millions of years ago, a time period when oceans splashed across the surface of Mars. And no, we're not claiming crabs crawled upon the ancient seashores of the Red Planet, but we know for a fact, from 3 different meteorites, that living creatures dwelled on Mars beginning 4 billion years ago, at about the same time life appeared on Earth. Some of these Martian microbes lived in a watery environment. Others dwelled within rocks deep beneath the soil and bathed in water which seeped down into the cracks within the rocks. Those microbes which died were fossilized when the water mixed with organic residue, creating carbonate cocoons which imprisoned their remains. However, when pieces of Mars were sheared from the surface and flung into space, this debris probably carried not just fossilized remains, but huge colonies of creatures that had not yet died, some of which fell to Earth. Be it Earth or Mars, ultimately we can trace their ancestry to creatures that arrived from space encased in all types of debris which in turn had come from other, more ancient planets. Other than the hand of God, there is simply no other logical, rational explanation. Our ancient ancestors, the first creatures to appear on Earth, journeyed here from the stars.